platform covered everything from idea to market-ready product. A platform teaching all the AI tech and practices needed for successful AI-driven startups.
This is like AI imagination.
We found that the more specific we are.
We used a classifier, we trained the classifier.
I really wanted it to just be more open-ended for the user.
We were experimenting with different chunk sizes.
Having some problems to something.
By blending cutting-edge technologies from industry giants, you can create revolutionary AI products that drive innovation forward.
This was a special hack, it was a battle.
Let the hacking begin.
AIstronauts, assemble! Welcome to the winner stream of the AIstronauts, Space Agents on a Mission Hackathon. Over the last weekend, you've done what most people can only dream of. You've built AI agents that push the boundaries of space exploration and redefine what's possible with AI. You created solutions that could one day power missions beyond the Earth. And now it's time to celebrate the best of the best. Tonight, we reveal the projects that made us say, just like real astronauts, Houston, we've got a problem. A problem to choose the winners, as you all did so great. Buckle up, astronauts, let's do this. My name is Joanna, and today, together with Jonathan Rundberg, lead automation engineer from LabNext, we'll be your hosts or your astronauts commanders for this incredible journey. So strap in, it's time to launch. Let's rewind to your mission, the Hackathon Challenge. You were tasked with creating AI agents that could revolutionize space exploration, automating tasks, optimizing workflows, and solving critical challenges. But this was not just about writing code. This was a mission to build solutions that space agencies can only dream of. And astronauts, you delivered. You tackled automation, making missions smarter. You optimized resources, cutting inefficiencies. You brought space data closer to everyone. To us, this is how the real change begins. The winning teams from this hackathon will earn a fast-track interview for the LabNext incubator program. You might ask, what does this mean? It's your chance to take your AI agent beyond the hackathon, get expert mentorship, refine your idea, and turn it into something big. This is not just a prize, it's simply a launchpad to take your prototype beyond this hackathon. The judges are looking for 4 key elements in your AI agents. First, application of technology. Does your solution effectively integrate AI models? The stronger the tech, the better. Then we've got business value. How practical and impactful is your solution? We're asking, can it make a real difference in space innovation? Then we've got originality. Your AI agent should be creative, unique, and push the boundaries of what's possible. And last but not least, presentation. Because if you cannot explain it, you cannot sell it. And before we move on to announcing the finalists, do not forget to keep the momentum going and sign up for our upcoming hackathons. What's coming up for you this February is first, the Generative AI Hackathon with IBM Granite happening this weekend from 21st to 23rd of February. And your mission is to optimize business processes with IBM Granite. The prize pool is $10,000, so definitely worth fighting for. And we've got for you all the cloud credits that you might need to access the tech that you need to complete the hackathon. And as all our hackathons with IBM, it's going to be super exciting. And then in 2 weeks, we've got the second edition of the AI for Connectivity Hackathon, the Building Resilient Networks edition, happening February 28th to March 2nd, both in Barcelona and online. So all the people who'd like to travel for MWC conference to Barcelona, feel welcome. And just before it starts, join us for the hackathon. And in the prize pool, we've got $5,000 for you, as well as the 6-week incubation program with Giga and LabLab next. We just wrapped the first edition in Geneva and it was great, so Barcelona is going to be even bigger. If you enjoy this hackathon, really do not stop here. Keep innovating, keep hacking, and join the next challenge. And now, time for the moment that you've been waiting for. The moment to reveal top 5 teams that made it to the finals. As always, our judges had a really hard time to choose the teams, and that only proves that you, hackers, are simply extraordinary. We want to thank you all for participating in this hackathon and let you know that LabLab is your place to be. We could only choose 5 finalists, but if you did not manage to get your project to the finals, who knows? Maybe you'll be the one for the next hackathon? Let's get straight to announcing the finalists. We've selected 5 best teams for this hackathon. So the first finalist is Team Nebula AI with their project Nebula AI, autonomous space mission control system. Then we've got Team Komu with their project ARMS, autonomous research management system. Then we've got Team Default with their project Humans to Mars, and up to other 2 finalist teams, Team Hackfinity with their project AI model for space education, and Team Space Ninjas with their project AstroClean AI, AI-powered space agent. The teams have been introduced in completely random order. I would love to congratulate to all the finalists. Your projects were truly outstanding, and now it's time to show them to the world. And not only as we tackle the challenge beyond the Earth. Here's how it's going to work. We'll play the presentations submitted by each team, and after each presentation, Jonathan will provide live commentary, sharing insights and thoughts on what makes each project stand out. After all the presentations, we'll take a short 5-minute break so that the judges who are here with us at the backstage can deliberate and choose the winners. After the break, we will announce the winners. So, let's begin. Let's start with the first presentation by the team Nebula AI with the project Nebula AI Autonomous Space Mission Control System. Let's see what they prepared.
Hi, we are Team Nebula, and this is Nebula AI, your autonomous space mission control system. Space missions are becoming increasingly complex, with satellites operating in dynamic environments where real-time decisions are critical. Traditional mission control relies heavily on manual processes, leading to delays, inefficiencies, and increased risks. Nebula AI changes this by introducing an autonomous AI system that optimizes satellite operations in real time, ensuring smarter, faster, and more reliable mission control. Space operations are complex, with manual systems causing delays, inefficiencies, and higher risks. As satellite networks grow, these challenges become mission critical. The global space industry is expanding rapidly. There's a clear demand for autonomous solutions that reduce risk, improve efficiency, and adapt in real time. Nebula AI is the brain of satellite operations. It doesn't just automate, it predicts issues, optimizes resources, and makes decisions in real time to ensure mission success. We tested Nebula AI using real data from the Cassini mission, simulating real-world conditions to validate performance and reliability. Nebula AI's architecture includes a data ingestion layer that collects real-time telemetry, AI core that detects anomalies, predicts risks, decision engine to automate tasks and resource allocation, simulation module to test scenarios to validate AI, and a dashboard to visualize real-time data and AI insights. Key features include autonomous mission planning, proactive anomaly detection, resource optimization, real-time decision-making, and simulation integration. Nebula AI offers full autonomy with predictive real-time adaptability, setting us apart. This is the Nebula AI dashboard, the mission control hub. On the left panel, you can navigate between dashboard, mission control, resources, and simulation. The system health metrics on the right display real-time status for propulsion, navigation, communication, and power. These values are dynamically updated by the Telemetry Monitoring Agent (TMA), which continuously analyzes incoming data streams. The mission timeline tracks the progress of critical tasks, providing real-time visibility into mission status. These metrics aren't just for display, our AI agents process them in real time to detect anomalies and trigger automated responses. Simulate an anomaly scenario. I'll trigger a propulsion system degradation. The anomaly detection agent, ADA, powered by machine learning algorithms, immediately identifies this deviation from normal parameters. The anomaly impact assessor, AIA, evaluates the anomaly's severity, assessing how it impacts current mission objectives. Recommended corrective actions, such as switching to backup thrusters and adjusting orbital parameters, are automatically suggested and displayed under active alerts. What's key here is that Nebula AI not only detects anomalies but predicts potential system failures using predictive analytics trained on historical Cassini satellite data. Now let's explore resource optimization. I'll simulate a sudden power surge. The Resource Allocation Agent, RAA, responds in real time by dynamically reallocating bandwidth, power, and storage to maintain mission critical operations. Priority adjustments, automatically shifting resource priorities based on mission criticality. The RAA uses reinforcement learning to continuously improve resource distribution strategies, optimizing performance under variable conditions. Now let's engage the simulation module. I'll initiate the Titan flyby simulation, a complex maneuver with high navigation demands. The mission planning agent, MPA, autonomously adjusts the spacecraft's trajectory based on real-time telemetry. Simultaneously, the task scheduling agent, TSA, reprioritizes tasks in response to simulated anomalies, ensuring mission objectives are met efficiently. System health metrics dynamically respond to simulation inputs, with real-time degradation and recovery visualized. This module allows us to validate AI performance under mission-critical scenarios, improving reliability in actual space operations. Power lies in its ability to process complex telemetry data in real time. Power and battery telemetry that monitors consumption and battery levels with predictive warnings for high usage. Metrics with Aufhängerstatation, real-time storage usage with alerts when thresholds are breached. Signal strength for new started patients, monitoring communication links for optimal data transmission. Resource usage patterns through heat maps indicating hourly resource utilization for trend analysis. These insights help operators make data-driven decisions backed by AI-driven predictive models.
For everyone who has just tuned in, we've just watched the presentation prepared by the finalist team Nebula AI, and the project was Nebula AI Autonomous Space Mission Control System. And now I'm really curious to hear what Jonathan thinks about that. Nate?
Yes. Hey, everyone. And thank you, Joanna. Yeah. So AI astronaut hack. This is a big market, and this market is just expanding more and more, especially when we have all these new companies coming and just launching rockets to space. And we cannot forget to mention about SpaceX and like hatching the booster after the launches. That just shows all the potential we have in space business. And Nebula, I think it's a great solution. We really need to find more solution that is more available for all these companies that start launching their satellites to space and how they can manage that as well. So making that more available to all the different companies who want to do their space missions, I think that's great. And if you're looking at a market, I think we're up to 380 billion almost by 2028. And looking at those numbers and thinking about all the new companies that comes and can shoot up their satellites and also have access to it, I think that's great.
Exactly.
Yeah.
Great market to explore.
For sure.
Okay, yeah.
So,
And
yeah.
yeah, sorry, Nate. Sorry for stopping by. Okay. And yeah, the only thing I wanted to add is that I am a strong believer in our lab hackers, and honestly, that's another case when we showed that our hackers can do better than Elon, same as at the Dodge Hackathon. Okay.
Yeah, and It's a prototype. It's a hackathon. Obviously, it's very early stage, but just looking at the potential and seeing how creative our community is, it's amazing.
Exactly. Thank you so much, Nate. And now let's jump to the second presentation of the day, prepared by Team Como. And the project is ARMS, Autonomous Research Management System. Let's see what they prepared.
Hello, we are Team Como. In space missions, astronauts face critical challenges like resource scarcity, equipment malfunctions, and also health emergencies. These issues can lead to life-threatening situations if not managed promptly. Similarly, during earthly disasters like earthquakes, hurricanes, and pandemics, people experience sudden resource shortage, requiring efficient management to survive. So we are introducing ARMS, or Autonomous Resource Management System, an AI agent that designed to monitor and optimize resource in real time. ARMS continuously analyze oxygen levels, food supplies, power availability, and astronaut health metrics using machine learning to predict survival time. So beyond space missions, ARMS has vast potential for terrestrial emergency response, disaster recovery, and also military crisis management. The global emergency management market is expected to reach $122 billion by 2025, highlighting the demand for AI-driven resource optimization. With this capability for long-duration space missions and real-world disasters, ARMS is a transformational AI agent redefining crisis survival strategies. So we already built several.
So this is our generative AI based application in which we have used Grok API for mission analytics and recommendation system. This is dataset where some information of missions and their relevant parameters is saved, and we will use it as our CSV file. I will upload that mission application. Here is the complete dataset overview that we have added here. Here we can select any mission from its given ID, and at the last we get predictions or recommendations on the basis of that specific ID of mission. Let's suppose I am choosing 6 ID, and here are all the information of ID 6 mission, and by clicking on get prediction and recommendation, the Grok API is fetching information, and this is giving us the overview, key observations like about distance, cost, and success rate. Also, it gives us suggestions for optimization like propulsion system, mission objectives, risk management, and future directions that we can take measures for our risks and our problems.
Okay, so welcome to the ARMS system, where astronomers resource management system, and this AI application will help all the astronauts to survive in emergency scenarios. Like this application, when emergency mode is on, then this application will activate it, and it will shows the total health status of the astronauts and all the resources matrices on their desktop on the front side, so they can now like their heartbeat and oxygen, blood pressure, and like their resources, food resources like energy resources data, and it will show in a graph way and also in a text way. And I think our AI chatbot will give him some suggestions like how to manage all of this, like how, like for physical health, what he could he has to use, and for sleeping schedule, and also about his nutrition, and also regarding mental and emotionally how he can manage all these things in that situation, and also to how he need to maintain his routine, and also communication with other teammates, and if he has some other team members, then about leadership management. So all this will application will guide the astronomers to survive in emergency mode. So, and the metrics, and this will show the total time within how they have to survive there. Thank you so much. This application built using Hugging Face LLM model. So, Mr.
And also, other than the functionality that we already made in the prototype, we also made the user interface that try to give a very easy to understand and a complete data that a user can see on the dashboard. So by this prototype, we want to show you that this idea is very interesting to be implemented on the scale, bigger scale, and hopefully with ARMS, we are revolutionizing survival technology, saving lives in space and beyond. So join us in building the future of AI-powered crisis response.
And that was the presentation prepared by Team Como with the project ARMS, Autonomous Research Management System. Nate, what do you think?
Look at that. Another great solution and another example of how creative our community is. So, yeah, as I said, this is a huge market and we need to incorporate more AI to it, obviously. And I think this is a great way of doing it because if we want to eventually go to Mars, we need to be as efficient as possible with all the resources we have because it is expensive. And using AI and predictive analysis and trying to be proactive with the health management and all of that, I think that's a great way of looking at it because if you're thinking about it, can't really be reactive when you're in space and you run out of, I don't know, something important, food, water, whatever, oxygen. It's super important. So I really like this idea and I really want to see how they take this further.
Exactly. I'm also really curious how and if the team will take it further, but I always recommend that. And I keep repeating on every single hackathon that the hackathon is just the beginning. It's just the moment to spark your creativity, to gather your team, to spend some super intense time on actually working on your prototype and then thinking after the hackathon how you can take it further. Like imagine if you want to launch your own startup and doing it without a time constraint of 48 hours takes so much time. It takes weeks or even months to get things up together. And on the hackathon, it's just a perfect way to do that. And you just simply validate your idea so quickly. And I believe that all the finalists have already been validated that they have a great potential to go with their solution to the market. So
Exactly.
yeah. So once
That's
again,
why we have Lab Next.
exactly. So also remember about Lab Next, you do not need to be a finalist of a hackathon to actually apply to Lab Next. You can do it anytime that you'd like. It's only about the hackathons that give you a fast track interview for that. Because we've got tons of applications and it actually takes
Indeed.
time to interview everyone. So a hackathon, great place to be.
Yeah.
Alrighty, and now it's time for the next team, third team of the day. So I'd like to show you the presentation of the team default with the project Humans to Mars.
Hi, Team Default here. So just imagine having all the latest Mars updates at your fingertips. Our platform Humans to Mars makes that possible. So first of all, let's talk about the challenges. The first main challenge is limited access. People most don't know much about Mars exploration. They do not have even much knowledge about Mars. And the second one is data disconnect. There is a lot of science, but it's hard to understand. People don't understand data easily. The third one is real-time info. So we don't get live Mars updates. So we have made that this very easy in our platform. People can get real-time visualizations by using Humans to Mars platform. The fourth one is engaging tool. People do not have much knowledge and they do not even have much interest in the Mars knowledge. So we have made this very interactive to understand Mars data. So now let's talk about the solutions. So first of all, there is a AI chatbot. User can ask anything about Mars and get instant answers. And the second one is NASA data, in which user can view real-time Mars information. The third one is interactive facts, in which user can learn, user can check the insights and keep himself up to date about the weather and the wind pressure of the Mars. And the fourth one is space quiz, which basically tests user data and enhance the user's knowledge about Mars. So now let's talk about the key features. First of all, there is a AI chatbot which basically uses Grok API and Llama model for the output, and the third one is, and the second one is NASA integration, which have used the NASA API for the real-time interaction and the data visualization. And the third one is weather data, which basically shows the insights of the Mars. And the fourth one is rover photos, which basically shows the pictures of the Mars. So now let's talk about the technical architecture. So for the front end, we have used Streamlit for the user interface, and For the AI functionality, we have used Grok API with the Llama 70B model, and for the data we have used NASA APIs which fetch the data from the NASA. And the fourth one is libraries. We have used different Python libraries for the visualization. So now let's talk about the design. We have made this design clean, modern and attractive, and the design is responsive, which is mobile friendly, and there is interactive chat which shows a real-time data to the user with the visualization. And the fourth one is quiz system which enhance the user knowledge. So let's talk about the impact and benefits. So first of all, there is accessible education. User can enhance their knowledge. Second one is real-time data. User can keep himself up to date about the insights of the Mars. Third one is interactive learning. User can learn and explore much more about Mars. And the fourth one is personalized response. User can keep himself up to date about the insights of the Mars. So now let's talk about the future plan. In future we will enhance the data. We will make data insights more better. And the second, we will add the community functionality in which the same-minded people will share their ideas and knowledge to each other. And we will convert this platform to the mobile application to make more user friendly. And the fourth one is API. We will use premium API to extend the data integration. Now let's talk about. So now let's check the demo of our platform. So first of all, we have an animation which attracts the user, and on our landing page there are some functionalities like latest updates in by which user can check the latest updates of the Mars. And the second, there is NASA astronomy picture. Basically this picture is fetched from NASA, and below this picture there is a summary of this picture, what this picture is showing. Here it is. So let's move to the next functionality. Next, there is a AI chatbot in which basically user can put their queries and get instant answers. So here are some common queries. So here it is. Here how it will work. So now let's move to the next. Next, user can explore the facts. So first of all, there is some information about Mars in which have some random fact. User can check it. So second functionality is geography, in which user can check the geography of the Mars by different angles. So here it is. And the next one is missions. User can check the active missions about Mars. And the next one is research. User can check the current researches on Mars. Just like the water presence, user can check the water presence or not. User can check the research from here. And next one is blog. User can read different articles for the enhancement of his knowledge. Now let's move to the next. Next we have NASA data, in which first of all user can check the temperature with the visualization, and there below there is a summary of the visualization. So here is the written the data source. Basically this data is fetched from NASA. Next, same like temperature, user can check the atmospheric pressure, then user can check the wind speed. Next we have re-over photos. Basically there are three types of photos. User can check by his own choice by selecting his own date, and below the photo there is a information about the photo. Basically this data is fetched from NASA. And the next we have the quiz. There is the quiz in a friendly way. First of all, user have to put his username just like that. So we have made this in a funny way. So here it is. User can check the mission stats and his score. We have just of all we have launched the mission. So if I get the right answer, so here it is. So it will also show the streak, one answer, one streak. So if I give the wrong answer, it will tell me the answer. If I give second wrong, it will give me the hint about the answer. So this is our application, how the humans to Mars will work. So that's all. We will wait for your valuable feedback. Thank you.
And that was the project Humans to Mars from the team Default. Nate, give us your insights. What do you think about that?
Yes, I like this. I like this a lot. Like Mars, the never-ending growing topic. And to be honest, I don't know too much about Mars. Like probably like everyone else, it's red and it's pretty far away for us to go to at the moment. but it's like when we wanted to go to the moon, but now it's the next phase. And having a platform that is interactive and with real-time data, I think that's amazing for all the space enthusiasts we have out there. And I know that is a community of people that are growing a lot. So I definitely see potential in the market there as well. So that would be super interesting to see more about in the application to LabLab Next.
Exactly. Like hype on Mars will end only at the moment when we actually can, like everybody can go to Mars, you know? So I think there's a lot of time for all the people who are thinking on some innovation on this topic. So yeah, definitely interesting. And that's a really great project.
Yeah. Imagine going to Mars in your computer. That would be great.
Exactly. Like
They're
imagine.
solving it.
True. And yeah, I'm really curious if in like 10 years from now we'll be able to go there, or that still will be too early. Maybe, you know, it will accelerate fast, same as like AI did lately. We'll see.
We like exponential growth.
Exactly. We love that. All right. So everybody who just tuned in right now, I'd like to remind you who were the finalist teams, as I see the question popping out in our chat. So the finalist teams are Nebula AI, Como, Default, Hackfinity, and Space Ninjas. And we've already shown the 3 presentations prepared by the first 3 mentioned teams. And we've got 2 more presentations left. So now I'd like to show you the presentation prepared by the team Hackfinity with their project AI model for space education. Let's see what they've got.
Welcome to Hackfinity's AI model for space education. Our AI model makes space education fun, interactive, and personalized for young learners aged 5 to 13. Engages children with visual quizzes, real-time responses, and make learning easy and fun. Space education is complex, and the traditional learning materials fail to engage children. Our AI model provides a dynamic learning experience, making space exploration really exciting and engaging. Our model has an AI chatbot that provides personalized questions with different learning levels, that is beginners, intermediate, and advanced. It also provides instant answers to space-related questions. Children can also do quizzes with a creative visual feedback to keep them engaged, like balloons all over the screen for correct answers and the red highlights on the wrong answer. This model has a very friendly and attractive interface for young learners. The goal of this project is to make space education engaging, providing AI-powered interactive learning, encouraging curiosity and critical thinking, and to offer a scalable educational solution for schools and parents. Challenges that we faced were ensuring accurate and simplified content for young brains, balancing both fun and education, optimizing AI to provide engaging user experience. The impact of this model is to make learning space science accessible and fun, can be widely used both at home and educational centers. Also encourages self-paced learning and curiosity. This model provides instant and interactive learning, personalized quizzes, and real-time feedback. Encourages kids to explore space through engaging conversations. The target audience is parents and educational institutes. Potential throughout the globe is that it can be expanded to multiple languages and a really huge demand for AI and STEM learning. Revenue streams include subscription for premium features, licensing AI for educational institutes, sponsorships and partnerships with space organizations, and in-app purchases. Competitors' analysis is that existing educational platforms focus on text-based content. Few AI-driven solutions cater to young enthusiasts. Our competitive edge is personalized learning, interactive quizzes, and real-time engagement. Our AI model is revolutionizing space education by making learning fun, interactive, and accessible for kids. With its engaging features and real-time AI capabilities, we are shaping the future of STEM education. Let's inspire the next generation of space explorers, one conversation at a time.
Have you ever wondered about our universe and what separates us from space?
The scale of the universe is incredible. When we look up in the night sky, we can see stars, but those stars are in our immediate neighborhood. They're the stars that are the closest stars to the sun within our own Milky Way galaxy.
The Milky Way is a spiral galaxy that both the sun and the solar system are a part, along with a bunch of stars clustered together that create a brightly lit center. At first glance from Earth, it looks like a wide path of light the ancients once described as a river of milk. It has a combination of two major and minor arms, two smaller spurs, as well as a collection of 100 billion stars.
Those are the same stars that you can see with the naked eye when you look up at the night sky.
But imagine how much more of the universe lies behind the lens of a telescope.
With Hubble, we've been able to see beyond the Milky Way galaxy. We can see nearby galaxies like the Andromeda galaxy that are interacting with the Milky Way galaxy. We can look beyond that and see galaxies that are colliding with one another. And we can see to the far reaches of the universe.
So even though it may seem like we're millions of miles away from the outer galaxy, we're only really separated by a thin layer of atmosphere.
Meet my team, Dare Maknoon, Malia Azim, Imran Khattak, me and Abdul Wasim. Thank you.
And that was the project AI Model for Space Education by the team Hackfinity. Nate, what do you think about that?
I think this is perfect. We all talk about what is happening with everything with space travel and all these adult things, but how do we keep the children in the loop? How do we make this to a topic they can start exploring in an early age? I think this is a great solution for that, having an interactive platform and learning more about space. I think that is crucial if we want to foster our youth to become more space-oriented and help us with our big missions to get further. So yeah, I love this. I wish I had it when I was younger, rather than the school books when you only had the sun and all our planets to go by. Now having interactive platforms and learning that way, I think that is amazing.
Same here. I totally love that. And I see the future of education in projects like that. So congratulations, Team Hackfinity. That is great.
For sure.
All right. And for today, we've got one last finalist team. And the team is Space Ninjas, and the project is AstroClean AI, AI-powered space agent. Let's see the presentation.
Hey everyone, it's Hiza Khurshid from the team Space Ninjas and here to present our project AstroClean AI. As you know that space is getting crowded with thousands of satellites in orbit, and space debris is a growing threat to missions and satellite infrastructure. AstroClean AI integrates AI, ML, and real-time simulations to track and predict debris behavior. Every year, space agencies face millions of dollars in damage due to collision with debris. With increasing satellite launches, traditional monitoring methods are somehow not scalable and lack real-time prediction capabilities. And that's why we needed a smarter solution. And that solution is AstroClean AI, which provides an advanced AI-powered solution for debris detection, classification, and collision risk prediction. Our system analyzes orbital data, simulates debris movement, and sends early warning to prevent any kind of collision. What makes AstroClean powerful is that it has AI-driven collision prediction that use ML models to assess risk, and a 3D space debris simulation that visualizes debris movement, and AI-based image classification that detects and categorizes debris. And lastly, it has interactive user interface which provides a user-friendly dashboard. To power AstroClean AI, we leverage cutting-edge technologies that ensure speed, accuracy, and scalability. For the front end, we used Stringlit and React.js to create an interactive and clean user interface. On the back end, we rely on Python and Flask, and for ML and AI, we integrate PyTorch, XGBoost, ResNet 50, and YOLO v5 that enables real-time space debris detection and classification and disk prediction. For data handling, we use Pandas, NumPy, and Joplib, and for orbital tracking, we utilized Trio AI and Skyfield. If we talk about the benefits of our project, then it prevents costly damage to satellites and space stations. It also improves space sustainability by reducing collision risk, and it integrates seamlessly with existing space agency systems. What makes AstroClean AI unique is that it has AI-powered real-time prediction system, an interactive 3D simulation system, and an affordable and scalable SaaS model. If we have a look at the future prospects, then we plan on expanding AI models for precise tracking, integrating with satellite network for real-time monitoring, and partnering with space agencies and companies, and lastly, launching an open-source API for searches. Thank you. Now let's have a look at the demo of our project.
Hello everyone, welcome to AstroClean AI, an AI-powered space agent which is used to monitor, predict, and prevent space debris collisions in real time. So there are three main features in our app. First one is collision prediction. The second one is space debris simulation. And the third one is AI debris detection and classification. Let's move towards the first feature, which is collision prediction. As you can see here, there are three parameters. First one is altitude, the second one is speed, and the third one is debris size. First, user select the altitude. As I can select it like 728, then user adjust the speed according to its need, like it's 8, and then adjust the debris size. And this model predicts the collision risk according to these three parameters, which is like 82.47%. Let's move towards the next feature, which is space debris simulation. As you can see here, there are two parameters. First one is time step hours, and the second one is number of steps. First, user adjusts these two parameters according to their need. Like I adjust first parameter as 2.70 and the second one is 320, and then I have to press the run simulation button, and it will provide me an interactive 3D plot. As you can see here, it provides us a 3D plot. Basically, this feature provides an interactive 3D environment to visualize debris trajectories and simulate possible collision scenarios. With interactive plotting, operators can analyze the impact of potential collisions and adjust mission paths accordingly, as you can see here in the graph. Now let's move towards the third feature, which is basically AI debris detection and classification. In this feature, our system basically detects the debris in the space images and classify them according to their size, coordinates, and risk level. So first we have to add the file here. I can select any image of space like this, and then it will detect the debris in the space image like you can see here and categorize them according to the coordinates, size category, confidence level, and risk level. So this is our whole project. Thank you so much.
And that was the last presentation that we had prepared for you for today. The team was Space Ninjas, and the project is called AstroClean AI, AI-powered space agent. I'm really curious what Nate thinks about that.
First off, I love the team name, Space Ninjas. Second of all, for me to feel a bit more safer on Earth, I want more solutions like this. Because as we talked about earlier, the amount of satellites and rockets we are launching into orbit, I want to see more people caring about how do we manage all of that debris up there, all the satellites and everything that is just going around Earth. So yeah, I like this a lot. And I think it's something we need to, find more solutions for. So I'm grateful to the Space Ninjas, that's for sure.
Yeah, super happy to have solutions like that presented in here. Like Nate mentioned, we need more of that. So congratulations, Space Ninjas. That was really great. And now As these were all the presentations we had for you for today, it's time to choose the winners. So we'll go for a 5 minutes break with our judges right now, as we've seen all the presentations, and we'll be back after a very short break to announce the winners. So stay tuned. We'll be back in just 5 minutes. See you soon.
Rage on that beat, going crazy.
Hello, everybody. Welcome back. And we're back to announce the winners of Astronauts Hackathon. So I must say that being on the backstage with the judges is not easy because hearing them deliberating last minute, like who is the best one, when everybody does so great, really inspiring to have you all here. And we're more than happy to have you participate on all these hackathons. But this is the moment to announce the winners. So let's start with the third place. So the winner of the third place for the Astronauts Hackathon is Team Como with their project ARMS, Autonomous Research Management System. Congratulations! Now, let's go to the second place of the hackathon. The second place of the Astronauts Hackathon goes to Team Default with their project Humans to Mars. Congratulations, Team Default. And now, the grand finale and the grand prize winner. First place of the Astronauts Hackathon goes to Team Nebula AI with their project Nebula AI Autonomous Space Mission Control Systems. Congrats, Team Nebula. And AIstronauts, trust us, the mission does not end here. Keep the momentum and join our next hackathons because believe us, you are the real talents in here and you are the ones who shape the future of AI. To all the teams, whether you made it to the finals or not, you took on a massive challenge and you delivered. You turned ideas into reality, tackled real worlds, or actually space, problems with AI, and showed us what the future of technology looks like. That is no small feat. Finalists, your projects are nothing short of inspiring. The work you've put in, the problem solving, the breakthroughs, it's exactly what the AI and space industries need. And winners, congratulations! You've proven that with vision, skill, and dedication, anything is possible. But let's be real. This hackathon was not just about the prizes. It was about learning, building, and connecting with an amazing community of innovators. So keep pushing, keep innovating, and never stop reaching for the stars. To the winners, LabLab Next team will reach out to you directly to manage your prize of the Fast Track to LabLab Next interview. And for the end, I'd like to remind you to follow us on social media to stay up to date with all the news we've got for you. And believe me, this year is going to be full of surprises. So thank you for participating, for being with us, and see you at the next one. Bye!
Rage on that beat, going crazy.